This conference will now be recorded.
Hello everyone and welcome to this new session. So guys, let us wait for 1 or 2 more minutes so that other guys, other candidates will join in the meantime. Okay, uh, let us start with the blockers. Any questions that you may be having?
Yes, I have.
Um, um,
Yeah, sure.
The previous docker on the first class, I have practiced that one on EC2 instance.
Mm-hmm.
And the last one you told us that like you are doing on your local system, I guess. So, uh, what will I have to do? Like I have to upload everything to Git and do that on EC2, or I can do on my local also.
No, I didn't get you, Chinmay. Can you repeat that first? What I've done in the local, can you, I maybe forgot. Can you tell me again?
Yes, you are doing in the first Docker class, like you are doing on your local system, I guess.
Okay,
So, but I have done that configuration and everything on my EC2 instance.
okay.
So, and now you have shared the documents. So, what will I have to do? Like, I have to upload everything into Git and then download those things from GitHub in the EC2 instance and do
Yes.
everything on there. or
Yeah,
I can.
yeah, you do the same thing. So upload it on your GitHub, and
Yes.
then just clone in on the EC2 instance, and then you can run those Docker file and the other file that I've shared with you.
Okay.
Yeah.
And I have one question also. Like you are doing something IP on some port 80.80 colon 80. Like uh,
Uh, so do you want me to share the rights with you, make you host?
no, no. Actually, I have done the first Docker class because I got confused whether to do or not on my local system. So that's why I did not do anything today. So
Let's do one
n-
thing. Let's do one thing. Let me share the access with you. You show me what you have done, right?
no, no. I have done nothing. Like the
Oh,
first
okay.
Docker class I have done and I have uploaded, and the
Mm-hmm.
second one I just wanted to ask that if I will do on EC2 instance or my local system. So
Okay.
that's why
Okay.
I did.
Yeah. So actually, because I have had that same on my local, Docker was already installed on my machine. So I
Mm-hmm.
started on my local machine only, and then I told you that my AWS was not working. So I have done it on the local machine only. But you can do it on your EC2 instance. But if I remember, if I'm not wrong, I
Mm-hmm.
think in one first session I have used the one I think Pahlavi's machine also, where I installed everything. But yeah, the file that I've shared with you, upload it on your GitHub, and then clone it on your EC2 instance where you install the Docker.
Okay, okay, I'll do
That
that.
would be fine. That would be fine. Yeah.
Okay.
So
So,
I was going through your comments also, Georges. So it seems that you will take some time to share um, the assignments. Okay, if it's possible, you can unmute yourself, Georges, and then we can talk. Okay,
Yeah,
okay,
sure.
okay. Sure, no problem. But that's important. So it would give you also confidence. So if you are doing it on the maybe, but I can understand that you have some work also. But try to finish it. Try to spend some time here so that you will be on this always on the same page what you are doing. Okay, no problem, George. So I think most of us are here. Sure, George. Thanks. So most of us are here. So let me start with the attendance first, and then we will continue through the blockers. Give me a moment, just. Okay. So let us start now. Do we have Farwa here? Okay, Farwa is not here. Zuhair Halak.
I'm here.
Thank you, Zuhair. And Jyotsna.
Yeah, I'm here.
Okay, thank you, Jyotsna. Jyotsna, I think you was not available on last Friday, right?
Yeah, I mean, actually, I connected, but I was waiting like 15 minutes, but I nothing was happening. I called the guy who told me that this is I new ID that you guys have to do start from today.
Okay,
But
okay,
I don't know what happened. Then, but again, I got the video. I thought, oh, then I saw that okay, the class is happening. Okay, yeah,
okay.
that's.
Yeah, sure, no problem.
Uh, and I'm in the progress of doing everything. So. I'll email you any questions that I have, and I'll submit the assignment by tomorrow morning.
Yeah, sure. That would be great. Yes. Thank you, Josna. And Kruti, do we have Kruti here? Kruti will probably ping me. Yeah, okay. Thanks, Kruti. And Kevin?
I'm here.
Thank you, Kevin. Ehtashimuddin?
Yes, I'm here.
Thank you, Mohammed. And Sravni?
I'm here.
Thank you, Sravni. Priyanka?
I'm here.
Yes, thank you. Chinmay? Yeah, Chinmay is here. So, next is Upama? Upama, I cannot see here. And then Mahmudul Hassan.
Yes,
Hello.
I'm here.
Yeah, yes. Thank you. Okay. And Judges is already here, so we are good. Upama and Farwa. Okay. So let's continue with the blockers, guys. Anyone else who have some blockers?
I had something. So,
Yeah, yeah.
so I did everything on the Amazon EC2 instance. Everything is fine, but one problem is in my local machine. I also want to do the same thing on my local machine on background. So I didn't find the file. You show me something to connect the Jenkins. I have to put something on the etc sysconfig and dockers. But
Mm-hmm.
on my local machine, I didn't found it because my machine is CentOS. Background machine is CentOS.
Okay.
Everything is installed fine. Other thing is working, but I didn't find the Docker file. Sysconfig inside the sysconfig folder.
Okay. So actually, this differs. The
Okay.
location, yeah, the location of the Docker differs. So it may be, I need to check for different distributions that may be in the different location. We need to check that.
Okay.
Yeah. So maybe, after the session, I'll let you know.
Okay, please. Yeah, that is the.
Yeah, sure. Okay. And any other question, guys?
Yes, I have.
Okay. Yeah, please, Mohammed. Yeah, ask.
Yeah, so I'm unable to start the Sonar Cube.
You are unable to start. Okay. So, have you followed the same,
Yes,
instruction that I have shared in the video?
yes.
Okay. So let me just share the access with you. You are now presenter.
Okay, so currently, so I followed the same steps, and then I'm trying to start the Sonar Cube. It's failing.
One more thing. How much space you have on your machine? I mean, how much RAM?
My laptop.
So you are running inside the EC2, right?
Yes. By
Um,
default, I selected 8, I guess.
okay. So you remember that I have selected one T2 dot medium. a bit bigger instance than the T2.micro.
I think I know what is happening. I think he need to update his Java version. It should be Java 11.
Java 11, right? I did.
Java is not here. Java is
So
here.
If Java version is 1.8, then never start.
Yeah, it will not start because it requires at least 11 here for this. This because this is the latest version of SonarCube that we are installing. It requires 11. So it seems that you do not have the Java installed.
okay, I'll download Java.
Yeah, install it and then it will be fine.
Okay. All right. Thank you.
Sure. Okay. Thanks, Pallavi. And any other question? Okay. So let's move forward then. So today I'm going to show you. I'm going to show you the two things: the auto scaling group, its policies, how we can set up the policies, and then how we can include the load balancer in the auto scaling group. So I have a kind of situation for you. So just to understand clearly. So I have an application which is running, and then let's say because of one of the product that this application have launched. So let's say take the example of Amazon.com or Amazon.ca. So they launched one product, and it's very much in demand because of its cost that they are offering. Due to that one, traffic increases a lot. So due to the increase in the traffic, the application is designed in such a way that they while testing they have in mind that okay, application can take up the load till 50 million users, but not, maybe not more than that. But due to this product, the traffic increases to, let's say, 60 or 70 million users. So what will happen in that case? Application, due to the load, it will crash simply. So crash means the system what machines that different nodes that are the part of the complete stack which is taking up the load. So if you remember, I have shown you the load balancer in which there were two machines which were taking up the load. So one of these two machines, what will happen is it will go down because of the increase in the CPU utilization, in the RAM utilization. The machine will become so slow that it will, at some point of time, it will be inaccessible, and that means that it will go down. And when the same load will come to the second machine, again it will also going to go down. In this way, application will go down and users will not be able to access the application. So now, in order to avoid this situation, so what we want is, so whenever the load increases, one more node will create automatically, and then application will be installed automatically, and then it will be the part of the stack, application stack, and then it will immediately start taking up the load. So now we are saying that there should be a scaling policy where if the load increases, instance will be add up to the cluster, and then it will start taking up the load. Same thing happens when, let's say, the load goes down beyond certain percentage. Then it will, at the same time, it will release the resources also. So let's say we have 6 machines running in our stack, in our cluster, which is taking up the load. So if CPU utilization is not as per the expectation on these nodes, so better to release one node and then check the load. If load again is very low, release the second node, again check the load. So we have a minimum desired as two or three, and running as 6, so it will release these nodes one by one by one if the CPU utilization is, or the memory utilization is beyond certain percentage. Now this is the situation we need to make up. Now on the on-prem, we need to write up all the scripts to do this one, or maybe we need to sit to manually do this same thing. But what about the what about if you want to do it automatically? Then on the AWS provides us this functionality through the um, through auto scaling groups, or setting up the auto scaling policies first, and then setting up the auto scaling group. So this is what I'm going to show you today. And so for that one, I'm going to first set up the launch configuration. Now launch configuration is basically the collection of attribute values to be used for launching EC2 instances. I will show you what do we mean by this one on the AWS. And then on the 8 auto scaling group side, we have different policies that I just mentioned you, like define minimum, maximum, desired in number of instances. So what should be the minimum number of instance? What should be the maximum? And then desired is optional. So, and then setting up the ELB and ALBs. I will show you this one also. ELB and ALBs subnets. So we are saying that now we are going to put the instances multiple availability zones, and so that if one availability zone goes down, then we have the instances in another availability zone which will take up the load. Then we have a cooldown period also. I will tell you what does it mean. And then we have the scale out policy and scale in policy. So we are going to cover this one, and let me try to see whether we can find out any picture, so that I can pictorically I can be able to tell you this same thing. So AWS.
You told me that when load is increased, then automatically new machine is created. But when
Yes.
load is down, then they will automatically shut down.
Yeah, they will automatically shut down and then terminate also,
Oh, okay.
and then, yeah, it will be out of the stack.
Oh, okay, okay, got it.
So if I see, maybe I can see the images here. Okay. So simple, we can find it here maybe.
I can see your screen.
Oh, okay. The same thing I used to do every time. I forgot to share the screen. So now you should be able to see the screen now. Okay. Okay. So let's see this one. A simple one, I think. No, no, not this one. Okay. So if you see this, we have this is the availability zone 1, and this is availability zone 2. Now in this, we have like web tier, and we have the application tier, and then we have the database tier also. So this is a three-tier architecture, application architecture. In the web tier, you can see that we have the web servers here, and two web servers in one availability zone, two web server in the other availability zone. Same thing with the application server, two in one and two in the other availability zone. Now at the top we have the what we can say, a kind of load balancer, which is sending the traffic. And then you can see here that in the web tier itself, like if due to the load in any availability zone, if instance goes down, immediately one more instance needs to be the part of the stack to take up the load. So now one is shaded and one is unshaded. So that means that what how we can be able to set up the policy so that always two instances would be there in one availability zone. So this is just for you to understand. And this is what we are going to create also. Like we will create the auto scaling group. What we will first we will set up the scaling policies. Then we'll create the auto scaling group. We will then create the load balancers the same way we have done it last time, and then we will make it part of the auto scaling group. And then what we will going to try is we will just try to shut down a few of the instances, and you will see that in some time the instances will all again be created automatically, and then they will be the part of the stack. So this is the problem statement, and I'm going to create the let me just log on to the AWS. So okay, so I am going to go for the okay, let me go into the EC2 first. On the left side you will see all these auto scaling group, auto scaling policies, everything, launch configuration and auto scaling group. So if you just scroll down a bit, you will see here we have the launch configuration. Let me click on it. Okay, and then now I'm going to create the launch configuration first. Create launch configuration. So let me just select this one. Let me select this one now. Okay, T2. And one more thing you can do is, guys, you can set up your AMI also. So let's say you have one EC2 instance which is running, and you have installed applications there. You can take the AMI of it, and then in the scaling like in the launch configuration, you can use the AMI also. Now I am using the this instances, proper instances, but you can use the AMI also. How you can use it from here, like my AMIs, whenever you create your own AMI, it will start showing up here. And then you can use the marketplace also, but it would cost you a bit. So you can choose it from the marketplace. You can have your own AMI, just select that, and then you can go ahead, select and configure details. Here, create launch configuration. We have to set up the name. So launch config, we can give the name. Purchasing option request, no, we do not require this. IAM role, you can set this up also. Like if the application which will run inside your auto scaling group, if it requires to connect to the different AWS resources through the API, then you can set up the IAM role also. That this is the perfect strategy to use. And then monitoring, we do not require monitoring for now. And then you don't have to give all these options for now. The default one is good. Next, add storage. This one is good. Security group, I will use the existing one. Select an existing one, this one. Review. So I think I'm good because I know this warning. and we should be good. So in this way, we are just setting up a the launch configuration. So think this way: whenever new instance needs to be created and needs to be the part of your stack, what instance it will choose, or what AMI it should choose to spin up the instance. So this is what we are setting up here. We are setting up the launch configuration. Once it is done, we will set up the auto scaling group. Create launch configuration. I'm good with the AWS key, this one. Okay, successfully created launch configuration, launch config. This is the name of it. And you can see the creation log also. Okay, you can see the creation log. And then create an auto scaling group using this launch configuration. Now I'm going to create the auto scaling group. Or I can say new auto scaling group, USG. Launch configuration, I'm using the launch config, the same one which I've created. So this comes automatically now because in continuity I've selected the button. But if you want to go, I mean, you can go inside, like, let me show you here. You can go to the EC2. On the left side you will see auto scaling group. Click on the auto scaling group. You can create a new auto scaling group from here also. Create auto scaling group, this option, and then you have to, it will give you the option to choose the auto scaling policy, launch configuration, sorry. So then you can select your launch configuration. Group size, start with, let me start with the 2 instances. That would be fine. And then VPC, I'm selecting the default VPC for now. I have to show you the VPC a demo also, how you can create your own VPC. Though I should have covered it before auto scaling group, but no problem. After this auto scaling session, I will cover the VPC. And then subnet, there are default two private subnets and two public. So I can select any one of it. So I'm selecting this, and I am both public. Okay. So I have chosen two public, two subnets, so that instances would be created in different availability zone. Okay. And then the advanced details. So load balancing, I will do it after the this setting up the auto scaling group. I will create a load balancer quickly. For now, it's good. Health check grace period 300 seconds. I will change it to 150, let's say. So this is good here. And then next, configure scaling policies. So this is actually the same which I was telling you. Scale between 2 and 4. Scale between 2 instances and 4 instances. This will be these will be minimum and maximum size of your group. So this is what I was telling you. Scale group size, average CPU utilization. Metric type is average CPU utilization. So now I'm saying is, if average CPU utilization uh, okay, target value, let's say 150. Okay, scale group size. So target value is the policy maintain the metric at the target value by adding or removing instances as required. So CPU utilization 50% is met. configure tags. So if I want to set up the getting the proper scaling policies, use scaling for just the capacity of this group. Okay, so yeah, increase group size. Okay, I need to add the alarm also, execute policy. So I need to set up an alarm also. So let's add an alarm. So I'm going to set a alarm now. I'm going to add one new alarm. So I don't want to send a notification for now. So whenever average, yeah, here we have this. Whenever average CPU utilization is greater than or equal to let's say 70 or 80, average CPU utilization is greater than or equal to 85, let's say, for at least one consecutive period of 5 minutes. So let's say for continuously for 5 minutes, the CPU utilization is greater than 85 percentage, then we can say that there are a lot of processes the is running for the application, which is increasing the CPU utilization for the last 5 minutes, and that's a situation where we need to have one more instance to take up the load. So I this is the new alarm that is going to be created. So what will happen in this case when something like this happens? What will happen is add one capacity unit, one instance. That means capacity unit is one instance when 85% is, so when the same this situation met, then add one instance. You can also say that add 10% of group. So let's say currently whatever the number of instances that are running, add 10% of it to the existing stack. But this is more appropriate to say add one instance, one capacity unit, and then take this action. Instance needs, let's say, 150 seconds to warm up after each step. Warm up means, once the health checks met, so it will also check whether, the application which is running on the instance is up and running, whether the health checks are met or not. So this is the warm up period. And the same thing, now here we are increasing the instances. Now there may be a case where CPU utilization is continuously low. In that case, we need to remove the instances also. For decrease group size, add new alarm. So here what I'm saying is when average CPU utilization is, let's say, simply less than or equal to 5, this is simple, or less than and equal to 10, let me just, less than or equal to 10% for at least one consecutive period of 5 minutes, this is the new alarm, create alarm. What will happen in that case where this situation met? Remove one instance when this situation met. Simple. This is what I wanted to set up. I set it up here. Configure notification, tags, review. It's all good. And create auto scaling group. Okay, now close. Let me go to the here. This is the new one. Try the new. Okay, so this is the new one, and let me just bring it up. Activity history. Failed launching a new Ether instance. It is failed. Uh, Okay, you 2A, 2B, and 2C. So it is saying that T2.micro is not supported in your requested availability zone. So US West 2D, I have selected 2D. So maybe I need to choose 2A, 2B, and 2C. That I need to do in launch configuration. I think I cannot change the launch configuration. For that, I need to uh, recreate it. So what I can do is launch, copy to launch template. New launch template is new launch config. Submit. Okay, so storage instance. Many things have changed here actually. This is new things that I'm seeing here. Let me just recreate it. It will not take much time. I created it from here. So let me create the new one. T2.micro configure details. New launch config. Nothing to be done here. Nothing in advanced details. Add storage. 10 is good. Security group. Oh, okay, sorry. No, actually, I am good with this one also. But I need to change the auto scaling group policies. Currently, scaling policy instances. Yeah, I need to change it here. Instead of 2A, let me select 2A. Yes, save. Now let us see the activity history. So you can see that we have two instances which are in service, and if I go to the EC2 instances, EC2 instances here, you can see here that three instances, because we have given here there three, so three instances are up and running here, and this is due to the same auto scaling group. And activity history, you can see here successful, and the third one is also successful here. That's awesome. Now what I'm going to do is let me create the load balancer. So or you can do the same thing, like you can create a load balancer and then make it a part of this one. So I can quickly do that. Here we have the load balancer. So create load balancer. I will create the classic elastic ELB, assign security groups, existing. I know this. I'll check. So it may be different. We may not be having the index.html. It may be different one. Or we can also check. Let it be index.html only. No problem. And then add EC2 instances. I don't want to add it now because I will add this uh, complete group into the auto scaling group. I will add the load balancer. So add tags, new, review and create. Okay, I will close it. Now I have this auto scaling group, and then let me edit it and launch configuration, availability, classic load balancer. I have new ELB, so I have added it up here and then save. You will see that automatically, though I did not have added the instances in the load balancer, here it will start up adding in the load balancer. You can see here currently these are out of service. So let me do one thing on these two instances. Though I know that there is no use of going to one instance and installing the application, but I can show you over here. uh, let us go to one of the instance. So I will take this IP and I'll go here, ssh -i downloads, AWS key.pem EC2 user at this. Yes, I will simply install sudo em install httpd. It's a httpd web server. In the meantime, let me do the same thing on the second one here. So yes, ssh-i downloads aws key.pem EC2 user at yes sudo npm install httpd. So there are two instances running in my as part of my auto scaling group. They are also the part of load balancer, and I have installed httpd here. So as a result of it, if I do wget, or you can so if you can do wget local host 80, wget is not here. No problem. So let me go to the here to the first instance and copy this. Come here, 80 port, which is default. You can see HTTP. It should be showing up. Why it is not showing up? What does it
You
mean?
need to start the process.
Can you say again, please?
I think you need to start the HTTPD process.
No, but it's running already running here, right? Oh, okay. So yeah. I have installed it, but I did not started it. Oh, okay. Systemctl status httpd. Yeah, so it's not running. I need to start it. Sudo start httpd. It started, and status you can see here. Now if you come here, sorry, it's you can see that the web server is up and running here, and I don't think we have the, let me check. So this is the default page actually. No, so it used to be the default page only. It always go to the default. So I'm good. And this is for the first machine. Let us see what, yeah, same thing we need to give in the second machine also. It started. Yeah, this is also running. So let me go to the second machine, copy. Okay, so now let us do one thing. We need to differentiate between two. So let me go here, vim var www html, then index.html. So the page is not here. cd var www html, nothing is here. Where it will be? Okay, cd etc, I need to httpd const.t. Wait, con httpd.con home. vi. So maybe I can be able to find out here where is the directory root. Document root it is showing var.html, but I'm not able to find the index.html there. You can see it says var.html. Okay, no problem. My motive is not to show you the this one web server, but what I want to show you here is, so now two instances are the part of this, and uh, here you can see is two instances are running, desired to minimum to maximum it can go up to 4, and then you can see two instances here in service. Everything is good. And so what I'm going to do is I'm going to delete one instance, terminate one instance from the from here. So let me do that same. I'm going to terminate one instance. Let me terminate this second one, and let us see what will happen then. Terminate, and activity here, what we can see is, so now it is, we have destroyed it, terminated it, this instance. Let us see what will happen in some time. That is shutting down. So what will happen is, once it is down, and then, once the auto scaling group configuration, it founds only one instance in the stack, it will immediately start, it will immediately create the second instance, and it will make it the part of the stack. It's terminated, and in some time you will see that policy here will be triggered. 24 2070. Yeah, you can see that waiting for ELB connection running. So launching new, you can see here launching a new EC2 instance, not yet in service, and here also you can see that one more instance will be pending. So here it created one more instance, and then after this is up and running, it will make it the part of the auto scaling group, and it will automatically be the part of the load balancer. So this is what I want to show you. This is something that we can implement for our application, so that that in due to the launch of a product, the load will going to increase. So what you can do, you set up the configuration in such a way where at least, let's say, if your application requires 5 instances, you set up 7 instances all the time, that should be up and running. And then after that, if load increases, it will create one more instance for you, and it will make it the part of the stack. So this is all automatic. You don't have to get into it to spin up the instance, then install the application. The best thing is that it is doing everything for you, though I did not have created an AMI with the same. So what you can do is simple. So that this instance is running fine, it have the httpd installed on it. This is very basic example. So let's say this, on this instance, your application is up and running with all the configuration. You just take the AMI, you take the snapshot of it. What you can do is, I think, image, create image. So this is the option. You create the image of your running machine. Once you create the image, it will be available in the AMI section. When you start creating, when you just click on the launch instance, it will be available on the left side in the AMI, and then you can be able to, so I can show you for you. Create image, instance ID, this one. In image name, you can give any image name. Maybe you can httpd httpd AMI. Let's say image description, image with httpd installed. Okay. So all these options, like, minimum 10 GB of storage, create image, request received. So it will take just 5 to 10 minutes, and then it will be available in your account in some time. So you have generated the request in 5 to 10 or 15 minutes, it will be available in the AMI. So what we have done just now is we have taken a snapshot of the running instance, and then it will be saved in the so when you click on launch instance, or let me just my AMIs, it will be available here in some time. This is what I want to show you. Cancel and exit AMI. It will be available. Yeah, so you can see here it is still pending. Once it is available, status is available, you can be able to see this AMI in the same launch instance on the left side. And yeah, and then you can use that same AMI in your launch configuration, and then the same launch configuration when used in the auto scaling group, you will have this application always up and running. So the advantage of it would be, when new instance would come up to support your application, it will already be installed with the application, so they just have to be the part of the stack. That's it. So guys, this is what I want to show you here. You can just do the same thing, you can practice it, but remember that there are things that will attract charges. So play it with it carefully, and as soon as you are done, just remove everything. So that's what I'm going to do. So any question here, guys, before I just remove the resources from here? Any question till now, guys? Okay. So well, do one thing, practice it, then maybe you would be having some questions, so then maybe you can ask that time also. No problem. So what I'm going to do now is I'm going to just remove everything, so you can see available here. And if I go to instances, launch instance, my AMIs, you can see here that we have one HTTPD AMI which is available. You can select this one, and when you select this and when you launch the instance, you will find that the HTTPD server inside it would be up and running. So that's okay. Cancel and exit. Okay, launch instance. Now what I'm going to do is I'm going to remove the auto scaling group first. Auto scaling group, action, delete, yes, deleting, launch configuration, action, delete launch configuration, yes, delete, load balancer, action, delete, yes, delete, AMI, I'll go to the AMI, action. Uh, where it is? Register. AMIs. Okay. So everything is gone. EC2 dashboard. Running instances. Now there should be no running instances. Shutting down. That's awesome. So now after practicing, I've deleted everything so that it should not attract any charges here. So the same thing you also have to do, guys. Now what I'm going to show you, let us take a small break of just 5 to 7 minutes, and then I will show you how you can create a VPC and why do we require VPC. And there are few important concept facts that you would be excited to know about. So we'll meet after 5 to 7 minutes and then we'll start with the VPC, guys. Okay, thank you. Okay, guys, so back again. So now I'm going to show you about the VPC. So there are a few interesting things about VPC. Let me just. So VPC is your virtual private cloud. So if you want, let's say there is a requirement that you have to create an environment. So this is real thing, real time thing. I'm telling you. So I used to create the environments on the release basis. Like whenever the team start working on a new release, on a new release. So my team's first responsibility is to design and create new environment for them, and then hand it over to them that environment. So we create new environments on the AWS, and whenever we do so, we create in separate VPC. So it's a virtual private cloud where you have one set of instances running independently and irrespective of any other instances that are running. So they will not going to talk to each other, but if they want, they can within the same AWS account, they can be able to do that. But if you are saying that we have a virtual private cloud where we need our complete stack of instances up and running, so you can see that in every account you will see one default VPC where you can create your instances. Now, VPC means, let's say you want to create a full environment. First of all, I need to allocate the range of IPs to that environment. That we call it CIDR block. And let's say I want to create environment for 256 instances. I will allocate the range accordingly. So there's a formula I'm going to tell you now. There's a formula accordingly. The CIDR range, the subnet range will be calculated, and then you can be able to create your VPC according to that range. So we have a concept of CIDR. So guys, just see it very carefully. It's very important. So new document, or there is no requirement of new document. Maybe we have this one. Virtual private cloud, we call it VPC. So in VPC we have the CIDR block.
I can see this.
Oh, I'm sorry guys, again same thing happens. I always forgot to share the screen. So I was writing something here. So we have a CIDR block, which is like actually the range of IPs that you need to allocate for an environment. So this range, the maximum range is /16. CIDR block maximum IP range is /16, and so how actually you calculate /16 means it's lot of IPs, and how much lot of are there I will tell you according to the formula. So let's say I want an environment with the separate VPC, an environment with 256 IPs. So what site range I should give? VPC with 256 IPs. I will give maybe /24. /24 would be 8, 2 to the 4 to the 8, 2 to the 4 to the 8 to the 16, 2 to the 2 to 64, 120. Yeah. So I will give /24. /24 for 256 IPs. Now, why I have given /24? There's a formula which is 2 to the power 32 minus 24 equal to 2 to the power 8, and 2 to the 8 is 256. So this is the formula which we use to calculate, which we use to apply to calculate the IPs. So let's say if you want, and the base range which we always put is the 32. 32 is always the base range against which we will put our calculated range to find out the number of IPs. So slash 24 is the one that I have put it here. So 32 minus 24 is 2 to the power 8, 256. So let's say I want less IPs, maybe 16. I need to create an environment with the 16 IPs. Then maybe I have to give uh, 28. So it would be 2 to the power 32 minus 28, which will be equal to 2 to the power of 4, which will be equal to 16. So 16 IPs. So if the other way of telling the same thing is, if you want 16 IPs, give slash 28 as a side range. Now, out of this 256, I want to divide this complete range into multiple subnets, subnets in multiple availability zones. First of all, I will divide it into multiple subnets, and then I will put those subnets into multiple availability zones, so that it would become highly available. VPC will become highly available. So taking this above example of /24 for 256 IPs, what I'm going to do is I am going to divide it into uh, maybe not 256. Let us take the example 64. That would be more convenient for us. 64 would be divided into 4 parts of 16 IPs. I'm going to show you the same. Now 64 IPs, what should the range I should give? 26 maybe. 32 minus 26 would be 6. 6 will be 16 to 32, 64. Yes. So for, let's say I will take 26 for 64 IPs. How? Let me show you. Again, the same formula, 2 to the power 32 minus 26 is equal to 2 to the power 6, which is equal to 64. 2 to the 4 to the 8 to 16 to 32 to 64. So this is 64. Now I'm going to divide 64 IPs into 4 subnets, and then we will put those 4 subnets into multiple availability zones. So how I can divide it? Let's say I will take the example of 10.0.0.0 to 10.0.0.15. So these are first 16 IPs, right? And then 10.0.0.16 to 10.0.0 16 to 31. Yeah, 16 to 31. It will be next 16 IPs. Then 10.0.0.32 to 10.0.0.47, because 32 plus uh, 32 plus 17, including, because it includes 32 also. So next 16 IP will be till 47. Next 16 IPs. Okay. And then from 10.0.0.48, 10.0.0.63. Awesome. So now the first IP starts on 0, last IP and just 64. So these are the 64 last 16 IPs. Okay, so these are the range. So this is the first range of IP. This is the second range of IP, third and fourth. Now we will put first two in public and the last two in private. Let us see how we will do now in on AWS. First of all, guys, tell me whether you understand this concept or not. This is a very important concept.
Can you please repeat that one more time?
Sure. Yeah, I can see. So I think Josna also joined now. So I can share this again. Let me go back to. So what I was telling you here is that VPC is the virtual private cloud, and let's say if you want to create your instances in a separate cloud, in a separate virtual private cloud, so how you can do that one? So first of all, you know that, guys, you may not be you may not have noticed that on your local machines how the ranges have been allocated. So actually the way is you need to allocate the range, and there's a formula to calculate the range also. So let's say if you want big range of 256 or 512 IPs, or maybe more than 1000 IPs, if you want that range, you need to, first of all, you need to allocate the specific range for your work, and then you can go ahead to create the multiple subnets of it. So if you give 16 is very big range, guys. You can calculate 32 minus 16 is 16. 2 to the power 16 is somewhere 10 is 64.
Is that similar to VPN?
VPN, you can say, yeah. So VPN is the way to get into your network, and then you can access your machines. Same way, VPC also, you can create your machine within this VPC, and then it will be able to move
Okay.
your machine. Yeah, there's some noise from your side. So it's just, yeah, it's somewhat similar to the VPN. Like once you are inside the VPN, you can be able to access all the machines. Same thing with VPC also. So once you are inside the VPC, you can be able to access the machines there. So you can run your machine in a separate VPC, and this is the formula. Formula is the same. Like just now, what I've done is I have created the subnets. I allocate the subnets for 64 IPs. So basically, I need an environment for 64 IP. So first of all, I designed my VPC, because if you mistakenly design your VPC wrongly, there would be a wastage of IPs, because then you cannot be able to use it outside. So let's say you have the requirement of 64 IPs, but you have allocated a very big range of slash 20 maybe, and slash 20 would be 2 to the power 12. It is 2048 IPs, 2048 IPs for 64 requirement. So due to that one, it is very important to design your VPC carefully and effectively. So let's say I have requirement of 64 IPs, just give slash 26 only. Slash 26 is 2 to the power 32 minus 26, which is 2 to the power 6, and 2 to the power 6 is again 64. And then what we have done is 64 IPs we have divided into 16 IPs, and we have divided into four subnets. So this is subnet 1, you can say. So this is subnet 1, this is subnet 2, this is 3, and this is 4. Now we have 4 subnets, which when I will show you just now, which we will run into 4 availability zones, so that your VPC would be in a highly available mode. So I have allocated just like the range will start from 0, and if it starts from 0, the next 16 IPs it will end at 15. So this way we have 16 IPs here. The next 16 IPs we have allocated for subnet 2, third we have allocated for 3, the fourth we have allocated for subnet 4. So this way we have allocated 16 IPs each in 4 subnets. Now there will be going to be a very interesting fact, like in each subnet, first 4 IPs and the last IP, 5 IPs will always be allocated. So first 4 and the last IP will always be allocated for internal purpose. So that means 5 IPs will always be allocated for internal purpose. We will be left with 11 IPs for the use, and that I will show you on the dashboard also. And it will happen in all the subnets. So now I'm coming here, and now I'm going to go to the VPC. So by default, you can see that in every region, so currently we are in the Oregon region, so and we have close to 20 regions, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 17 regions. No, we have one more, 18. So we have close to 18 regions, and in every region you will find one default VPC always. I'm going to create the new VPC. Click on launch VPC wizard. Actually, the AWS have changed a lot. So you can see here creates a 16 network with a 24 subnet. Public subnets, you know, they have changed a lot of things here. So create VPC. Oh, okay. Here we have. So now I'm going to create the VPC. I can say uh, simple patch 5 VPC, or I can say fifth VPC. Cider block. What I must be valid IPv4 cider. So you can put it like this one. For example, this one. So we'll take this one only. 10.0.0.0 slash 26 slash 26 means 64 IPs. You know that, guys, right? 26 means 32 minus 26 is 2 to the power 6, which is 64. We need 64 IPs. So no IPv6 header block. Imagine, so the default one is good. Tenants is default. Yeah, it is. So VPC is created now. Fifth VPC, and I'm going to create the subnets now. Create subnet. Uh, what I will say, public subnet A, public subnet A, VPC is fifth VPC, availability zone. So what I will put is, let me take A, this availability zone, and IPv4 cider block 10.0.0.15. This is what I have to give. Slash so if I do not forgot what it will going to be 26, then it will be 28, because I need to divide into 16. So 28 would be 2 to the power 4. Yeah, it would be 28 here. 0 slash 28. Okay, so this is the full range. Now I am dividing into the range of 16 IPs. So there would be 4 subnets, and slash 28. This means 16 IP from 0 to 15. Same thing we have jotted down here also. Let me just refine it here. Subnet 1, 10.0.0.0 slash 28, and this is how slash 28 would be divided. And then the next would be 10.0.0.16 slash 28. Yes, and then the next would be, the first one is this 0 to 15, 16 to 31. Then it would be this slash 28. Okay, and then here the same thing. 32, 64, here it would be 48 slash 28. Yes, so this would be fine. So I've given slash 20 this one. Next I will give this. Okay, create. This is created. I am going to create the next one. Public subnet v. VPC is the same one, fifth. And now guys, if you availability zone okay, to B. Now if you again try to give the same one, it will give you error. Or if you give some if you will not give the proper range, if it will give you error. So if I give 15, just press tab, it will show you must be a valid IPv4 side. If I correct it, it will not, it will be good. So initially I have given from 0 to 15. I mean 0 slash 28, it will create 16 IPs. That would be until 15. Next we'll start from 16 for the next 16 IPs. Slash 28 is 16 IP for the next 16 IP, which will go till 31. Create, close. I'm going to create the third one also. Name this time private what I've private subnet C. This to C. Now I need to take the proper range, because if I will not give the proper range, it will give me error. If I give here 31, it will give me error. I need to give the proper, which is from 32 32 to next 16. Create. Then I will create one more subnet. The name private, private subnet D, the last one. Fifth D. Here you need to again give the proper range. Create. So now I have four subnets, and guys, you can see here available IPs are 11 only. Why? Because I told you first four and the last one out of 16 IPs, first four and the last one is being allocated for private use, internal use. So we are left with 11 IPs. That means we are left with 44 IPs. Now I have created the subnets. Now I have to create the route tables also. So guys, let's do one thing. I know that you need to understand this thing, because and I don't want to move forward. And you tell me this thing. I can understand. I don't want to move fast, because it will be tough for you to have everything, practice everything at the same place. So I will stop here. This is what I think actually. I think that I should not move forward, because I we have we saw the example demo of auto scaling group, launch configuration policies. We have done a lot of practicals today, and then I think understanding VPC, the calculation part, maybe you need to set for some time to understand it first. Then maybe if we create the same VPCs tomorrow, it would be more understandable to you. If it is not the case, if you want me to move forward today, let me know that one also, guys. It's all open to you. But what this is what I think actually. I think that we should do it tomorrow. That would be more helpful to you. But if you think otherwise, let me know. I have no concern over it. So, do you want to do it tomorrow? Maybe by that time you will practice the today's practicals also.
Yes, I think so.
Okay, because this is what I think. If I move forward, that would not be tough thing for me, but it will be tough for you to understand and absorb everything, and then practice also. So I think this is the same thought with every one of you also, guys. But if any one of you think otherwise, please let me know that one also.
It's okay. I
Okay, sure. So that's good. So let's do one thing. You come up with a question, practice these things, and then you come up with a question. Tomorrow we will continue from here. So tomorrow my plan is, we will. This is the VPC is one thing that I want to show you, and then I want to quickly show you the IAM part also, AWS IAM part, and then we will see how we can quickly configure the AWS SDK, software development kit, on our machine, and then how we can be able to, whatever we are doing manually, we can be able to trigger it from the AWS our terminal also. So these two things, it will not take much time. Then we will start with the Ansible tomorrow. And then now, guys, listen very carefully. This all these things are very important from the industry perspective. We are going to start with the Ansible, Terraform. We already done Docker, and then once and these are very very interesting automation things. When you start working with the Ansible and Terraform, you will feel yourself in the completely in the automation world, because whatever we are doing now, I am doing it manually, creating the EC2 instances, creating the AWS ALB load balancer, VPC. It will all be done through the Terraform itself from your terminal, and that is the correct automation that is in demand in the market right now. So saying this, please send me your questions. Practice all these things. It's very important. and let me know if you have any questions in the initial 5 to 10 minutes session daily. Please have those questions at that time also. And if you have any question right now, please ask me. If not, I we can call it off.
So I have something pending. So you told me you will find the configuration file on the background.
Uh,
Uh,
okay, so let's do one thing. I will ping you that one because it's been a long time.
okay,
Because
okay,
it's
it's okay, it's okay.
on the AWS instance. It's in the etc sysconfig docker, but there are other configuration locations also. I will share those location and try to find out your file on that location. Right,
Okay.
Pallavi?
Oh, okay, okay. Thank you.
Yeah, sure. I'll do that one, sure. So, okay, guys, thank you for joining this session today. Tomorrow we will be joining on the same link, same time, and thank you so much for today.
Thank you.
Sure.